The next example for lesson 8.2 is number 19. This one I had worked out just as an additional example for simplifying these radicals. So for this one, we again are going to use that quotient rule for radicals and break this down so that we have the square root of this numerator, 27x to the 7th, and then the square root of y to the 24th power. And then we're going to go through and simplify both the top and bottom of this rational expression. So the square root of 27, we're going to break that down so that it's the square root of 9 times the square root of 3. And this x to the 7th, we're going to write that as, just like we did on number 16, we're going to write this as x squared, and then square root of x squared times the square root of x squared times the square root of x. So that's how we can break that apart into its perfect square factors. And then the ones that we can't end up taking the square root of, we'll just end up leaving as a square root. On the bottom here, you could do that same method where we could write the square root of y squared times the square root of y squared, and we would end up doing that 12 times. Or we can write this using our power rule for exponents. And so we would have the square root, and this would be y to the 12th squared. So if we can write it as some power of 2, then what's going to happen is when you take the square root of that, that essentially cancels out. So our denominator here, we're going to be left with y to the 12th. Here, square root of 9 would be 3. And then writing out, we have x times x times x. So I'm going to write those all next to the 3 since those all simplified. And then here, the square root of 3 we couldn't do anything with, and then we couldn't do anything further with that square root of x either. So now just cleaning up the top here, we'd have 3x to the 3rd, and then this we're going to write together underneath the same radical symbol. So you'd have square root of 3x, and then that's all over y to the 12th power. So that would be the simplified answer for number 19. Now for number 20, same idea. So since we have this quotient underneath the radical, we're going to use that quotient rule. So this is going to be the same as doing the square root of 50 x to the 4th over the square root of y to the 14th. So we're going to rewrite this top part as the square root of 25 times the square root of 2. And then with this one, it really doesn't matter. I'm going to write it as times x squared times square root of x squared. But again, you could also write this. So the square root of x to the 4th would be the same as x squared squared. So you could do that instead of this x squared times x squared. Doesn't matter, both of them are going to get you the same exact answer. And then for this bottom part, we're going to use this idea like we wrote up here, and same as what we did here for y to the 24th power. Instead, we'll have y to the 7th power squared, and again, we're taking the square root of that. So now we're going to be able to simplify this. So we're going to have 5 times the square root of 2 times the square root of x squared would be x, square root of x squared would be x, and then this is all over y to the 7th squared, taking the square root of that, you would be left with just y to the 7th. Cleaning up the top here, we would have 5x squared, square root of 2, all over y to the 7th. And that would be the final answer for number 20. Number 22 has us using cube roots. So again, knowing your perfect cubes, at least the first few, can help with this. So for number 22, we have the cube root of 81/8. So we're going to break this down into the cubed root of 81 over the cube root of 8. Now 8 is a perfect cube, so on the bottom we're going to have just 2. In the top, we want to try to break this down into a factor that's a perfect cube. And so in this case, it's going to be 27 times 3. So we're going to rewrite this as the cube root of 27 times the cube root of 3. And so now this just ends up being the cube root of 27, which is 3, times the cube root of 3 all over 2.